Hello folks, this is 8.5. We're working with logarithms. And then we have these properties that I'll just briefly review. So we have the product property, where if our value there can be written as two factors, we can split up that log with the base and write it as the log with that base of one of the factors plus the log with that base of one of the other factors, or the other factor. If this value can be written as a fraction, we can rewrite this, or it's equivalent to the log of that base of the numerator minus the log of that base of the denominator. And then if we ever have a power, we can take that power and put it in front of the log. So it goes right there. Different ways of rewriting it. So in numbers 1 through 6, it says use the properties of logarithms to rewrite the expression in terms of log 2 and log of 7. Then use log of 2 equaling this, approximately that, and log of 7 equaling approximately that to approximate the expressions. So for number 1, I want to rewrite this either as log of 2 some way or log of 7. Now I have no idea how I would make this become log of 7, but I do know that, so check this out. 4 is the same as 2 times 2, right? So I could use this property. I could write log of 2. Now when I multiply values together to get this end result right here, I can split it up as, again, that log of the base of one of the factors plus log of that base of the other factor. So log, now by the way our base is 10 here, so we don't need to write that, plus log of 2 again, my other factor. Can I write this as a factor of 2 and 7, since that's the game that we're playing here in these directions? Yeah, it's the same as 2 times 7. So I can write log, it's base 10, of 2 plus log base 10 of 7. So we're just trying those properties, folks. Now they did want you to approximate the answer. So since log of 2 is about 0.301, I can make this become 0.301 and then drop down the plus sign. This is equal to 0.301, and that equals 0.602. So that's the answer. Whereas here, this is 0.301, but then the log of 7 they tell us is about 0.845. So I'm going to add 0.845 to it. So I get 1.146. That's the final answer. That's the approximated answer. So here I have a fraction, and so when I have a fraction, I can separate that into the log bases being subtracted. And it's really important that it's the numerator that starts and it's the denominator with the log that gets subtracted from it. So it's going to be log of 7 minus log of 2. And now I substitute in our approximations for those values. So it's 0.845 minus 0.301, and you get about 0.544. Similarly, we have a fraction here, so we can separate that into the logs being subtracted. So log of 2 minus log of 7. Again, notice that the order of the fraction, the numerator and the denominator, were switched, going from problem number 3 to problem number 4. So it's really important that I follow that consistency of putting the numerator in front, or being log of 2 first, and then minus the denominator, so log of 7 second. And when you subtract numbers, the order matters. So it turns out that when you take 0.301 and you subtract 0.845 from it, you're taking away more than you have. So you get a negative answer. So it's negative 0.5, negative 0.4, negative, seventh time's the charm. Negative 0.544. I don't know why it was so hard to remember or do that I just took that decimal right there, and it's going to be the opposite of it. Alrighty, so how can we write 49 as log base 7? There's actually a couple of ways, but the way that I'm going to do it is I'm going to write it as log of 7 plus the log of 7. Using kind of the rule that the product rule that I used in numbers 1 and 2, I'm going to call this 7 times 7. So log of 7 plus log of 7, so 0.845 plus 0.845, and that's equals 1.69. There's a second way you could have done it. You could have called it, I'll do it in blue here, you could have called log of 49 equal to the log of 7 squared, and then that power you put out in front. So you could have said, hey, I have 2 log of 7s. Well, log of 7, 2 of, that's multiplication. So I have 2 of 0.845. Guess what that equals, folks? Well, what you had over here was 2 of them. 2 times 0.845 is the same as 0.845 plus 0.845. Boy, how am I going to write log of 8 using log of 2 or log of 7? Well, what can I do to a 2 to make it become 8? We can only use things that are base B or powers. Well, so log of 8 is equivalent to the log of 2 to the 3rd power. So then we can rewrite this as 2, the log of 2 times 3. I put that 3 out in front. So 3 times the log of 2. So that's 3 times 0.301. Which equals 0.903. Let's keep applying those properties. So I've taken those properties and I've put them with numbers 7 through 12. Or you could look at the left side of your notes or your packet. Here that is. Expand the following expressions using the properties. So here I have factors. So I'm going to write it as log base 2 of 3 plus log base 2 of x. By the way, folks, when we're multiplying after the log, you can expand that to addition. And when we've been dividing, we can expand that to subtraction. If you're not in my class, you might be like, where do those letters come from? I like to write PEMDAS vertically like this. And so we bring the operation level down one level. So there's our expanded form. So here, when I'm dividing the value after the log, I can change that into subtracting those values with the same log base. So log of x minus log of 5. When I have a power, I'm going to bring that out in front. So this is the same as 5 log base 3 of x. I'm going to rewrite this, careful before we start trying to apply the properties. The square root of 2x is the same as 2x all to the power, and I think that's supposed to go all the way over. We're going to say it goes all the way over. It's the same as 2x to the 1/2, right? So now I have a power. I'm going to bring that power out in front. Zoop. So it's the same as 1/2 the log of 2. And then I have a product in here as well, so I can rewrite that as the log of x, or plus the log of x. But that 1/2 goes in front of this log, and it goes in front of the other log as well. So there we are. Same thing, power goes out in front. So -3 times the natural log of x. This goes out in front, the power goes out in front, so I have 2 log of base 3 of 27. I have a product here, so I'm going to change that to adding the same log of that factor. So 2 log of log base 3 of x. Condense them. So now we're going backwards. They've done the subtraction. How do I rewrite that with just 1 log base 3? Well, when we're subtracting the same logs and bases, we divide the values afterwards. And it's important that the first one goes on top and the second one goes on the bottom, right? Here is my first one in this example. Here is my second one. The b is second, so it goes on the bottom. Alrighty. So what's going to happen here? If we just look in the yellow on number 14, what yellow? That 2 is in front of this log base 5 for this term, but it's not for that term. So that coefficient of 2 is going to become a power, but just on the x. So I can rewrite this as log base 5 of x squared. And then remember, when we're adding the same logs, we can change that into multiplication. So I could write times 3, but I'm going to actually put that 3 in front of the x squared. For multiplication and addition, it doesn't matter the order. So log base 5 of 3x squared. Again, this 1/2 only belongs to the x because there's not a 1/2 in front of this log. So I'm going to write log. Now I notice that I'm subtracting. So when I condense it, it's going to turn into division. So on top, the first term goes on top. So it's going to be x to the 1/2 or the square root of x. Means the same thing. And on the bottom, I'm going to have a 4. Here I'm adding all of these log base 4s. So I can write it with 1 log base 4 by multiplying all of those values, the 5, the x, and the y together. Number 17, I see we have a multiplier out in front, so I'm going to turn that into a power. I have a multiplier out in front, so I'm going to turn that into a power. And I'm subtracting these different logs. I shouldn't say different logs, the log base 2s. Notice we can only use these properties if they're the same bases, and this is base 2 and that's base 2. So I can rewrite this with 1 log base 2. And then after that, I'm going to have x to the 2/3. And because we were subtracting the different logs, it gets condensed into division, and it's going to be y to the 3rd on the bottom. Last but not least, I see that we have log base 3 here. There's no coefficient here. There is a coefficient there, so that's going to turn into x squared. Log base 3, when I add the logs together, I turn that into multiplication. So it's going to be 4x. And then again, the x is actually being squared. And there we are.